Hi, my name is Michael Smith, Distinguished Engineer at Cisco, and I'm within the NCME Business Unit. I'm here today to talk to you about ACI Programmability, and this has been an area that I've been focusing on now for a little while. I thought I'd start off with some of the fundamentals of the object model, since that is the focus and the key component of the whole system. All of the programmability and everything you see that's accessed through the GUI, the CLI, all goes through this object model. And then I'll go into the REST API itself, because above and beyond the object model, how it accesses it is very powerful as well. And then we'll look into two components which sit on top. There's one is the Python SDK that's provided, which is a full replication of the object model. And we'll go into the ACI Toolkit. And if we have time at the end, hopefully I can do a little show and tell and show you some examples of what it's capable of doing. In terms of layers of APIs, there's essentially two. One you've probably heard about is OpFlex, that's underneath. What I'm going to talk about in this presentation is the northbound API coming out of the APIC. That's the one where the object model is. That's one where you're going to end up programming to, writing scripts. And that's the one that we have the GUI, the CLI that's been written is also communicates through this. So all communication, all accessing, all of our automated testing that we do is all through this REST API. The object model itself is essentially the full representation of everything inside the APIC. And there's really, I would call it three classes of objects. One is the policy view of the world, where you have application profiles and contracts and endpoint groups. Those are abstracted essentially away from things that the traditional network topology. Then you have the network policies. Those are the VLANs, the contexts, we call them, which are essentially VRFs, if you're familiar with the Cisco terms. And then you have the physical topology, which is the nodes, the links, the switches. So typically you would operate in one of those three universes, and largely the application, the policies is where you would spend most of your time, right, configuring endpoint groups and contracts. All of this is formed in a management information tree, so it's a hierarchy model. You'll see this in most REST APIs. There's a lot of objects. Remember, this is a large data center system composed of multiple sites, and we expose everything. So everything that's available in the system is exposed through objects. So there's roughly 6,000 plus classes of objects. So there's a naming convention that we use to define the packages. So when you look at the object names, there is an encoding scheme, because when you have 6,000 things, you want to encode them uniquely. They either get really long or you use something to compress the names. So you'll see things like FV tenant, that's fabric virtualization. You'll see things dealing with contracts as virtual zones, VZs. All of these objects form a hierarchy, but there are relationships across them as well. So you can have essentially graphs within this tree. So that's how you would have endpoint groups talking to contracts, talking to other endpoint groups. Essentially everything is an object in the system, and they're organized in this tree. There is inheritance in a sense that goes through the tree, so you can see properties propagating down. There is a consistency across all of the objects, so once you get a feel for them, they all have attributes. They all typically have naming properties, and you can go through it and analyze them, and there's children, the relationships to other objects as well, which are also objects. So everything as you go through the system, you're dealing with these objects, and it's pretty consistent across. Example of information tree. So you would start with a root. Everything is in there. The policy universe flows here, and you're seeing things like the tenant, application profile, followed by endpoint groups. And you can see the names are, they have some encoding within them. For example, the EPG is the FVA EPG at the end. There's filters and contracts and entries. But each object is essentially queried using a distinguished name. And distinguished name is essentially, you could think of it almost like a URL. And the URL gives you a walkthrough on the hierarchy of this management information model. So I know this is a little whited out here, but when you would walk this tree, you're essentially forming the URL to get to that object. So that means you can either query everything below that tree, go exactly to that particular object, and change or query it for its attributes. For example, if you want to access particular objects, such as the endpoint group here, you would query it using a particular URL. So you would go from the policy universe, you would go to a tenant. Within that tenant, you go to its application profile. Then you would go to its EPG, which is inside that. And that builds up your distinguished name to access that object. Similarly, you would access all the physical topology in the same way. You're starting from the same policy universe. You walk down, but you're walking down a different aspect of it. You walk down the topology side of the tree to get to the physical node. And then you can get to the interface statistics. And again, there'll be relationships across them. So if a particular interface is connected to an EPG, there'll be a relationship object that connect the two.
Are there limitations in the distinguished names, such as someone decides to create one called test/dev for whatever reason, and then it would interpret that as a sub at that point? So as to say, don't use certain characters?
Some of the objects do have, there's a full management information model that describes the naming constraints of certain, and typically the naming properties where you're going to run into the constraint. Most of the objects have descriptions as well, so you can put free flow text in there. But yes, there are some, for example, you can't put a slash because that would make the DN think it was another level, right? Those sort of things. So this object model is front-ended by the REST API. And the REST API is like any REST API using basic HTTP access methods. The nice thing is that it's idempotent in the sense that when you go and create an object, you can create it many times. If it's already been created, doing the same operation again and again is essentially a no-op, right? It's which becomes very useful when you're writing scripts. You can actually write something very simply, push it to the APIC, and not worry about if I push it again, am I going to create n versions of this thing? Or if I can just run it over and over, I can ensure that I push that config. For instance, let's say your APIC or your code crashes, right? And you want to run it again. You don't have to worry that I'm going to overwrite config. You can just push the same config as many times as you want. We call the get null, I don't even know how to pronounce it, but nullipotent. It's essentially a no operation, meaning it doesn't matter how many times you call this thing, it won't actually affect what's on the APIC. So when you do gets, you're not actually going to damage anything, right? When you do posts and deletes, you can change objects on the APIC, but it's that's all what scripting is all about. Right? When you look at a read operation, there is essentially a very familiar looking URL type format. You go HTTP, the access method, where you're going to the APIC, the API itself. You can specify managed objects or classes. So that allows you to do pretty wide queries. You can query all the tenants, for instance, by looking at the class of objects. You can say, give me all of the tenant class. You can use the MOs to go very specific. And then we populate that with the DN. So that's, am I looking for a class? Then I'll give it the class name. If I'm looking for a specific object, then I can give it the path to exactly where in the tree I want to pull that information from. You can specify whether it's XML or JSON. If we get to the demo, I'll show all JSON because I am not exactly an XML fan, but and what we have at the end is where the real power comes in. I think we have this very extensive filtering capability, which is shown at the bottom. We have an example where we can do a query target filter, and in this case, we're looking up for interfaces that are of 10 gig, right? So you can essentially query any specific thing with any value, and you can use wildcarding as well. So you can get very, very granular. And one of the more powerful things is you can actually subscribe to these queries. So there's a WebSocket interface that will produce any changes in those objects that match that query, which means that you could query for interface event changes, right? State changes. When a link goes down, invoke my application.
Is this the same for statistics as well, or is it just for config or state changes? So if I wanted to monitor bandwidth or something, interface errors or something like that.
Right. I haven't done it myself, but I believe you can query any particular object. Now, in the statistics, I would have to check on that. It's a matter of specifying the exact DN, but I think it's possible. So in order to create, what you would do is you would post configuration. Here we're showing XML being posted to a particular DN. So we're creating, essentially here, attaching an EPG to an interface. So within a tenant, we have an application, we have an endpoint group, and it has a relationship to a particular interface, and the encapsulation is a VLAN. So we're using VLAN 1 as the endcap in this case. So this is how you would define going to the raw REST API. So there are many filter options, and I'm not sure if you can see it from the back, but you can query full subtrees, and you can say whether I want a query to be on that particular object, I want anything below that object. You can go deeper and say what I want in the response, what I want my query to be accessing, and what I want you to return as part of that query. So all of those capabilities are there. Any question on REST API before we go on to? So we also have a ACI SDK, and this is a full representation of the object model in Python. This is automated, automatically generated. Its code name is Cobra. The Cobra SDK is on GitHub, and it's generated from the APIC REST API. And the object model itself. Essentially, you can go on, pull it, and install, and you can write exactly to those objects that we had there mentioned, like the FV tenant. You can create all of these in a Pythonic way. We also have what's called the ACI Toolkit, and this is where I spend the majority of my time. What the ACI Toolkit is, or initially, was the goal was to take the existing user base of the typical network guy and get him into this new model, right? So for a lot of networking folks, going from a world of CLI to the DevOps mentality, where everything is automated infrastructure, it's quite a leap. So we want to take something where you have these concepts of ACI and you understand those. How do we accelerate and help folks to get to that point where they can, they are using the object model and taking advantage of all the capability that's there. So we wanted to address the 80% use case. So we want to look at, okay, let's reduce the number of classes that give the ones that people typically use on a day-to-day that you would use in your normal daily operations. And provide as many examples and scripts that we could provide. So we create a simplify object model and then provide lots of examples. Because when you're writing code, what's the first thing you do when you hit a problem? You go to Google or you go to Stack Overflow and you do some searching, right? And you find, hey, 15 other people have the same problem. And so that was kind of the idea here, is provide as many things, show all the capabilities and provide examples. And then when people look for it, they'll find it, hopefully. So at the core, what is the ACI Toolkit? It's a Python library. It sits, you would run it locally, either on your laptop or a server or something, and communicate with the APIC. It wraps that REST API, so it'll hide a lot of the details, but it still makes the REST API available. You can think of it like a helper library. It does provide a simplified object model because we didn't want to duplicate that full object model. This is not generated. This is hand-coded. And it preserves a lot of the basic concepts, meaning you still have EPGs, still have contracts, you still have all of these concepts, but we want to wrap it in a way that you're not dealing with thousands of objects. You need to only deal with a handful. And on top of it, we've built a number of applications and sample scripts. We actually built a lot of commands as well. So for instance, one of the applications we started with was the CLI, and eventually proved to be very valuable, and we put it into the actual product. In the core of it, there's basically three things you can do. One is push things to the APIC. So you define a configuration, you define your full three-tier app, and you can push the full network config. You can generate the JSON. So if you want to define it in these simple classes, you can actually just generate the JSON, see what's it going to push to the APIC. And then if you want to go in and modify that JSON, turn whatever nerd knob you want to enable, and then push that final product to the APIC. You can pull from the APIC and see things in a very simplistic way. So you can, meaning you see contract classes and you see tenants. You don't have to go through the full APIC object model. And you can subscribe, and I think that's where a lot of the power in the applications comes in. You can subscribe to events and then act upon those events by pushing configuration. So we've started by writing a lot of applications on top of this, and that's really what we've been using to drive the toolkit as we move forward. We started with, and these are a few of them that are listed, all of this is up on GitHub, and so all of the samples, all of the applications are there. We have the CLI, we have a cable plan application that generates the XML cable plan from your topology, and you can compare that to what you actually thought your cable plan was. There was an endpoint tracker, but now we have this also in the APIC. But originally it was an application that would subscribe to endpoint events, and it's roughly a page of code. And you subscribe to endpoint events, and you receive the event, and you push it into a MySQL database. So you could run this in your lab, just sitting there on a typical Ubuntu server or something, and it would just log all of the endpoint connecting to a database. And then what you can do with that is go back and actually query it and say, okay, what was on my network on February 2nd between the hours of 10 and 11 a.m. And it would all be in your log, right? That you would have everything. Because in ACI, everything on the network shows up at the APIC. We wrote a lint. If you're familiar with lint within programming languages, you can actually do things like it does static analysis of the code, right? So you see where there's things, the code compiles, but there may be issues with it that doesn't match either style guidelines or things look a little fishy. What we did was a lint for configuration. Right, so we have configuration of ACI. What happens when you create an endpoint group, but you don't put it in a bridge domain? Right, so it's not able, or a contract that's actually not being provided by anybody. It's perfectly legitimate config because you may be in the middle of doing something and it's sitting there. But you can run this tool and it will tell you issues like that so that you can say, okay, these contracts are actually crufty configuration that nobody's actually using. We can remove them from the configuration. We wrote a multi-site application, which actually is in production in customer environments where coordinating the policies for endpoints across multiple sites. There's a number of reporting applications where you dump full details of everything because we do have a very extensive object model. So you can run this reporting tool on a particular switch and it'll give you a full output of everything that's in all the tables and everything that's being used as IP addresses, VTEP addresses, anything you would need in debugging the environment. Some of the other ones we have connection searching. That's an interesting one where we actually, it comes with a full-blown GUI. You type in 2 endpoints on the network and you say, hey, can these 2 talk, right? And it'll go through and figure out all the contracts that apply between them. It'll look at the networking configuration and figure out whether, in fact, these 2 things can talk or not, and display what applies. We actually did a configuration snapshot and rollback tool. That comes with a GUI as well. What it does is snapshot the JSON configuration from the APIC, store it into a Git repository, and you can run it to schedule as often as you want. So we have it running in the lab. It runs every 7 minutes. And just snapshot the APIC config and store it. Git is very efficient at storing source code changes. And in the end, a JSON configuration looks like source code. So snapshots that. And you can go back at any point in time and say, okay, when I'm debugging, what did the configuration look like, on that February 7th between 10 and 11 a.m. And then you can correlate that with the endpoint tracker, and now you have visibility not only into configuration but operational state. And the nice thing is with these applications, they can all build upon each other. It's almost like microservices. They all have their own, typically an API that they can communicate with, and they're running independently. So what we did was those snapshots of the configuration, we actually took those JSONs and actually wrapped it in an HTTP web service and made it a fake APIC. So now it can handle, when you send it a query, it can actually respond. So now we have this fake APIC there that you can query it just as if it was a real APIC. It's responding back with the JSONs that you took from the snapshot. So you can run analysis tools on it on a snapshot that you took 3 days ago, just like you could run analysis tools on the APIC through its REST API.
That's pretty cool. So if something you wrote broke after a change, you could go back to a previous iteration and test those same gets. Is what
Exactly.
you're saying. Okay.
Exactly.
Cool.
Mm-hmm. That's cool.
And one thing we found was we can actually simulate a lot of errors that we normally wouldn't get in a real system. For instance, when you connect to an APIC, typically you wouldn't get a drop connection in the middle or a bad error code. With this, I generate all sorts of bad errors in the middle, delays, simulate a VPN that's only sending a byte a minute, and I could really test out the toolkit applications themselves, and it makes everything more robust. So in terms of what the toolkit, how we develop it, it's all open source. It's community driven. We've had customers and partners and field folks all get involved. And when I say field folks, I mean system engineers out in the field working with customers, not the business unit. And it's been pretty exciting, the interest level that's been rising. We use fully automated everything. We want to, in a sense, learn with the customer. So we're using all of the DevOps kind of mentality. Everything is cloud hosted. We run through shippable.com. We use Landscape.io for the source checks. We run Jenkins in our lab to do continuous integration in the sense of we run full testing in our lab with an APIC. So every time anybody in the world changes a line of code and it gets committed, we do a full suite run on the APIC in our labs. And we deliver it pretty much every way you can think of. We have the direct pull through PyPy, through a pip install. We have containers. Docker is built every time somebody checks in some code. We update Docker. We have a VMware VM that self-updates itself when you run a script. And there's a Vagrant install as well. So here's some of the URLs for some of these things. We have a few minutes left to show some examples, if you'd like, of what we can do. Just leave that up for a second if you want to. Okay. Well. Let me see if this works. So this is our GitHub page. As you can see, there's a number of directories. What we have is really two classes. One is samples, and in the samples, you can see there's quite a few scripts in here. There's a tutorial in there that walks you through line by line, and that's in the Read the Docs repository so that you can go through the documentation and look at it. But most of these commands are short one-page scripts that show you how to do one thing in particular. So you can, typically they're either show commands. So I want to say, think of a iOS style, I want to show endpoints. Right? There's a script that will show you that, and it prints it in a format that looks like a CLI. And then there's other ones that are configuration, meaning you push a full-blown data center config, right? And most of those are very short. So, for instance, just do a quick show endpoints. So this is the entire code to show an endpoint, and I know you're not going to be able to see it back there, but there's a few lines of code to actually get the endpoint. The rest of this is pretty printing into columns. But to log on to the APIC, you're essentially calling what's called a session, and we just pass it the credentials, very quick, and then you do a login, right? So you log in. What's happening behind the scenes is that there's threads and things that happen to re-log in, and so that it doesn't time out. So one of the things with typical network folks, you may not know multi-threading, Python, and all of this details, so that we hide a lot of that behind the covers, and so it'll just happen for you. But the code is all open source, so if you want to get deeper, you can go look at the code and modify it. And the other side would be, say, configuration examples. And here, pulling it down, but essentially when you go and create a tenant, you just create it. If there's a tenant class, and you give it a name, right? Application profile, you create an application profile, you give it a name, and you give it who's the parent. The parent is that particular tenant. We're creating EPGs. Then we bridge domain context. Here it's creating a contract. You can see we have the database EPG. And then here we're going to provide that particular contract, which is a MySQL contract with one entry. So you can build up these configurations very quickly, push it. And to be honest, within the labs, this is how we do everything, because it's so much faster than going through a GUI, right? If you're going to do it more than once, right? And let me just see here. Oh, it actually looks better on the screen than here. But if we were, say, I could just show endpoints. You run small applications, and it's a little slow because of the VPN, but you can show little applications like this where you write it in a page, get a full dump of everything that's on this live system. This is in our lab right now. See, a lot of the MAC addresses are kind of hokey because they're static. You know, we insert them. We can also, where did my, sorry. I had an APIC. Oh, sorry, here it is. Anyways, this is a little slow, and I think I'm running out of time. But we can also push a full-blown configuration to the API, which would be that script where we say this is the EPGs in the contract, and it would show up here. And clicking through and showing the configuration that it pushes would probably take longer than I have left. But
Said something about creating the CLI with this?
Yes.
And then that was put into the product. So that was the NXOS style CLI that we were talking about earlier?
right. Yeah. So we built that in Python running, and the same code is not the code that went in the product, but we proof of concept all of that CLI that you saw on the board earlier. It was,
But it's just an abstraction, right? I
Well,
mean,
that particular one was a full shell, kind of with the config mode. You can go config G and.
It was a comfort thing. It was created to make people feel comfortable, even though it's not an actual.
yeah, it's a warm
Well,
sensation.
Not necessarily, because a lot of people, with multiple products across the board, find that troubleshooting situations in the middle of an outage is very difficult when you're clicking, right click, go to this menu. They want the CLI because it's just 100 times faster.
I agree.
Yeah.
As a CLI guy.
Yeah,
That's where I like it the most. That's what I'm the most excited about.
yeah. I think where we went from one end, the extreme, there's everything is in CLI to everything is in REST API, but in the end, CLI gets you to information so fast that configuration-wise, REST API beats it all day long, right? But debugging,
Debugging, yeah.
it's it gets you
Initial
exactly-
setup, let me create what I'm comfortable with. I know it now. Let's extract that out and then replicate that a billion times. Versus trying to do it initially from an API standpoint. This is a pain. Oh my God, oh.
It's like Google, when you go to their website, what do? It's a search bar. It's essentially a CLI, right? Get information quickly.
For someone who is just going to get started with that and has no programming experience, do you suggest going to the ACI Toolkit and starting there? Or do you guys have a resource that's a little bit more introductory?
Keep in mind, I'm highly biased because I work on the toolkit. But I would recommend going to the toolkit first, because there is extensive tutorials that go through line by line of
The
how
samples, to read the docs, that stuff looks like useful.